Hi everyone. In this video, we will graph a linear equation in standard form by plotting points. Graph the line by plotting points. Negative 2x plus 5y equals 20. This is not solved for either x or y, so it doesn't matter which variable I select numbers for to substitute in. So we're going to make a chart here, and it's x and y, and I still like to start with my very favorite 0. And we can also put 0 in for y. That's my other favorite. And we'll come up with a third point. I'll come back to that in a little bit. With these, we have to do a little extra work because it's not solved for one of the variables. So I'm going to try and write a little smaller so that I can fit all of my scratch work in here. With the first one, we're going to substitute 0 in for x and solve for y. Negative 2 times 0 is 0. 0 plus 5y is 5y. To solve for y, we'll divide both sides by 5. So y equals positive 4. So we have the coordinate 4 for y when x is 0, or the ordered pair 0, 4. The next point, I chose the 0 for y because, again, 0 is my favorite. It makes things so much faster when we calculate. So we're going to substitute 0 in for y, and we'll get negative 2x plus 5 times 0 equals 20. And this is the reason it's my favorite. 5 times 0 is 0, so it cancels out, and we're left with negative 2x equals positive 20. Divide both sides by negative 2, and we're left with x equals negative 10. So we put this into our chart, and we can write this as the ordered pair negative 10, 0. Now we're looking for one more number to plug in for one of the coordinates x or y. But sometimes we end up with crazy fractions. The best way to avoid getting fractions so that it makes it much easier to graph is to take a number that we already got that is a whole full number and add one of the coefficients from in front of the opposite variable. So here I have the number 0 for x. The opposite coefficient is 5. So another good point to pick would be 0 plus or minus 5. So we could pick positive 5. A different approach would be to take one of the y values, 4 or 0, and add the x coefficient, which is negative 2, and we add or subtract that to either of those. So we could do 4 plus or minus negative 2 for a y value. Either way, this method will give us full whole numbers that we can graph instead of trying to graph fractions, which isn't very accurate when we're graphing by hand. So I'm going to pick the number positive 5 for my next coordinate. Either way, it doesn't matter. So we could do the plus 5 because we added it to 0, or if we add or subtract the negative 2, we could have substituted in positive 2, or we could have substituted positive 6 in for the y coordinate and solved for the x. Either way works perfectly fine. So I'm just picking the 5. So we'll go ahead and do negative 2 times positive 5 plus 5 times y equals 20. Negative 2 times 5 is negative 10 plus 5y equals 20. Add 10 to both sides, and we end up with 5y equals 30. Divide both sides by 5, ends up y equal 6. And you'll see that this number 6 is a whole number, which makes it much easier to graph on our graph than if we had found a fraction. So this ordered pair is positive 5, positive 6. Now let's graph each of these points on our rectangular coordinate system. Starting at the origin for 0, 4, the 0 says we move no directions left and right for the x value, so we stay on the y-axis, and we move up positive 4, 1, 2, 3, 4 on the y-axis, and there's our first point. The next one is negative 10, 0. We start again at the origin, and we move negative 10 in the x direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our next point. And for our last point, we go to 5, 6. So we'll start at the origin again and move in the positive direction for the x-axis, 5 units, 1, 2, 3, 4, 5. And then from here, we will move up 6 in the positive y direction, 1, 2, 3, 4, 5, 6. And here's our next point. Then I'm going to use a straight edge to graph my line as accurate as possible. So I'm going to hold my straight edge over my paper and connect all of my points. And there is our equation graphed on our rectangular coordinate system. And now we're all done.